Welcome. So let's get into what we have to cover in this session, and that is Lambda function. In the last class, we looked into exception handling and everything around raising exceptions, handling exceptions, defining custom exceptions and stuff like that. So today we are going to be moving on to Lambda function. So what's a Lambda function? Another name for it is anonymous function, you know, anonymous function anonymous function. Now, so a lambda function is, a small, simple, simple in terms of what it does, not in terms of readability, most especially. Lambda function is not something and this is just like my opinion, it's not something I'm a big fan of, but and it is because of its usage really. Like if you I read through code bases, projects where I see lambda functions, I was like, okay, this person should not have used lambda function for something like this because it can get really really um unnecessarily complex to read really. But you're going to see what I mean. So a lambda function is a very small in terms of what it does, uh, function, anonymous because they really do not have a name at the point of definition. So we store them in kind of like variables. And it is defined using the lambda keyword. We don't define it with using def. In the previous classes, I think maybe 2, 3 classes away, we looked into how to actually create functions itself. Now, normally, let's say we have this function. Let's say def, and let's call it increase by 5, increase by 5 by 5. So it takes number as input and it return number plus 5. Then we can call, sorry, increase by 5 and we pass in 10, right? So if we run this, we get, what do we get as output? We get 15. Now, this function is really very simple, right? If you agree with me, like it doesn't really do anything really. And the way functions are defined in Python, I don't know many programming languages, but in Python, functions are, defined in a way that is very, very elaborate. Functions are defined in a way that is very, very elaborate. Like imagine we had to do def increase by 5, number, return number plus 5, stuff like that, just because we want to set up something that increases an input by 5. So to avoid this elaborate kind of things, to just have something like a one liner that quickly gets the job done in situations where there is no process. From our usage of functions in the past, you've seen functions in the past, like a lot of things goes here, some line here, like let's say l- line here, another line here, then like that, till we get to the return. But then in this particular problem, we are not doing anything. We are just like input, then the return is the output. So in that particular situation, like in situations like this, it's better to use anonymous function, because this is just like a one line solution. So it takes, any number of arguments. I'm talking about lambda function. It takes any number of arguments because this could be any number of argument really, and it returns the output. The output, and it just contains only one expression, right? So there is no like multiple things that you can do inside. So firstly, if you have to do multiple operations, even if that multiple operation or those multiple operation can like be, if you can stuff them into one line, you shouldn't do it, right? You should always use this normal function. But if it is just one line, something that does like something like we've done here, then you should probably use an anonymous function. So let's write anonymous function for a lambda function for something like this. So how do we do that? So we can say Let's call this new one increase by 10. Increase by 10. And like I said earlier, anonymous functions don't really like have names, right? Like the way this one says def increase. So we save them inside a function. So we can say, and this is the structure of an anonymous function. We are going to go lambda, like this lambda, the way we've written it like this. And the input, the first part of it is the input. So what is the input here? The number. So you can do number, we can just do x. So I'm going to say X. And the second aspect of it is the return value, like what it should do. So because it is not elaborate, just like this particular function here, it is not elaborate. The process happened on the output part, which is this. So that is the reason why um this works best for a lambda function. So we are going to say the first thing that goes in is the input after the lambda, then the next thing is the output, which essentially also is the process. So we can say x plus 10. So if I should come here now and say increase by 10 of 5 and we run that, we get 15. So this whole long line here, this def increase return number, all of those stuff, we've passed it into just this one line of lambda function. And that is basically what lambda function is, right? It helps us to, write simple function that we can discard, just define it, discard it, and we are done. All right. Now, if we do increase by, let's see, increase by 10, and we give it 25, we get, sorry, excuse me, we get 35 out. So we can reuse it like a normal function is, but it is not just elaborate. That is just the thing. Like the definition of it is not elaborate. And now we can also have multiple conditions. So imagine we have, I'm going to just keep coming back to this particular place to modify this function, or maybe not. Now let me just do that. So we can say a function that adds two numbers together, for example, adds, let's call it def add, and it's going to take no let's just say x and y instead of number one and two. X comma y, and it returns x plus y, that's all. Returns x plus y. And now we can call add, your normal function now, say add, then you can say 10 and 15. Well, again, this should not be a normal function. You should not define something like this in a normal function. You should define it with a lambda function. And how do we do that? We can say, let's call it simple add, and that is going to be, this takes two condition. Nothing has changed. It's going to be lambda, and it's going to be, let's say, a comma b, right? And it is going to return a plus b, a space, let's add space. You don't, if you don't, it's fine, but just makes sense. And here also you could do that. Now the next thing is to just say simple add, and we add 23 and 10, and if you run that, we get 33. So it takes 23 and 10, adds them together and gives us 33. And you could do anything. You could do anything, as long as it is not something serious. And you could maybe get averages. Let's say you want to get averages, you're going to say get underscore averages, and that is going to be lambda, and it is going to take your list. Let's say you take your list, and your list is a, and you can do the output is going to be sum of a divided by len of a, and you could get averages of 1, 2, 3, 4, 5, and you run that, and you get 3.0. So it's basically just like one, anything that requires one line that can be sorted in one line, you should um, use that with a lambda function. And I cannot just say it enough. You should only use lambda function one when the function is simple. It is very simple. That is one. The function you are using is only ones really or in line, like you don't intend to like call the function elsewhere. And the reason why that works is this: well, you are not doing annotation, you are not where do you want to do annotation? For example, let's say this is something that I want to like use multiple times across multiple projects or across multiple files rather, sorry. I can annotate and say I can do int here, I can do int here, then says it returns, maybe float, if I expect it to return float, yeah. Or even float here actually. Say float here. Or you could do union, int or float, you could do union of that. When we get to um actually we can do that anyway. So you can do from typing when we actually get to modules, and do from typing import, then you can go union. So that way you can actually union thing. You can say union and say, okay, this could either be float or it could be int. And the same thing here also, union can go int, or float, something like that. Then on the output here, you could do that too. So you could do that here also. And now you want to just, return your float. And if you run this, you still get your output. But another thing that you could add is you can say, add this and say this function does blah blah blah, blah, like that. So if we run this, now let's say I go several cells away or several projects away, and I say add, and I call this. Now, can you see? It's giving me like this nice thing. It says, okay, x takes either float or integer, y takes either int or float, then it returns float, right? So the thing here is, and it is also explaining what the function does and all that. You don't get that with lambda function. Even if you do type annotation, if you do type annotation, because you can actually int anything, you can even you can actually annotate anything. You can also annotate variables. So let's say you do int, which I don't even think you can do in a lambda function. I've never really tried to do it before. So I guess you can't because it's showing us this. So if we run this now, yeah, you can't. So that's another thing. I was thinking you can because I was thinking we can, and it turns out we cannot. That's impressive. So that's even like more reason why you probably shouldn't. You should not do this if it is something you want to use later on somewhere. And you can actually int a variable because I can come here and say salary, which is going to be a float equals 55.6, and it's going to work. And whenever I put salary here, like I call salary, like it's going to show that it is expected to be a float. Can you see? It's expected to be a float, right? So, well, you cannot do that with lambda function. You cannot int anything. So, if you want to use the function elsewhere, like in a far away place, let's say several stuff away, you should not define it as a lambda function because you're probably not going to even know what it means anymore, and you are going to be searching everywhere to understand the implementation. So that is another um, case where you shouldn't use the lambda function. So another time that you should not use it is that you should, okay, I'm talking about when you should use it. So the first one I said is that you should only use it when your function is simple. Second thing is when you intend to only use the function one time and one time alone, like you're not using it anymore anywhere else. Then you want to write compact code in a way, like you just want a one liner, you don't want your code to be extremely long and all of that. So now, when should you not use lambda function? You should not use lambda function when you want to put together a complex logic or multiple statements. You should not. It does not make sense. It does not work. It's a terrible idea. it violates one of the key things in writing good code, which is readability. It's just going to make everything really bad. So yeah, that is how to define lambda function. But then the true beauty of lambda function comes up. Let's take one more just to refresh our brain. Our let's just like get it behind us. So let's say we want to write a function that that returns the number of letters in a word, something like that. So we can go num underscore letters, and that's going to be lambda word, sorry, word, and it's going to be len word. So if I should come here and say num letters of, you can go word equals Femi, and you run that, we get four. There are four words in Femi. Femi Lola, we get eight. Right? Easy stuff, simple stuff. But the true application of lambda function comes with some other things called map filter, and there's one other one called reduce also. So let's come here and say using lambda function with map and filter. So if we come here now, how does that work? So let's, before we even look at how to combine um lambda function with map and filter, let us actually look at, let's firstly understand what map does. So map is a thing that it's a implementation in Python that helps us to apply a function, whether built-in function or a function that we create ourselves, on elements in an iterable. And this is what I mean. Let's say we have a function called, where's that function at the top? No, don't let us use this one. Okay, let's even use type. Type is a built-in function, and by run type of 45, it's going to say integer. So let's say I have a list of things. Say I have a list of things, and this list contains 2, comma 3.5, 3.4, comma true, comma 4 again, and comma good, like this. And I want to quickly check the element, like the type of each of the elements in this particular list. How can I do that? I can actually say something like this: list map type, that is the function type, with things. So if I should run this now, it's going to print out all of the types. So it's just equivalent of running this, something like this, which you can do with either list comprehension or with a for loop. So I can say for, I can run it like this. I can say for thing in things, then print type, or you can just call type. I don't know if that is going to like print out. I'm guessing it's going to print out type thing. If I run that, okay, it did not print out, so I can just print type thing, which is going to be different, but still it's like the same thing. So this is like the equivalence of what we just did. So we have int, float, bool, int, string. This kind of like the equivalent. Now, so this guy just took each of this, each of the elements in here, and was applying this function, this type function. It was applying it to it. So type 2, type 3, type 2 is integer, type 3.4 is float, type true is bool, type 4 is int, and so on and so forth. So that is what map does. So map helps us to take a function and apply it. So if I should have a function that gets, let's see, do we have another function that is not lambda function here? Uh, so let's say I have a function that returns square, something like this. Def get, let's say def get underscore square. Then if I go here and say x, and it return x star star 2. So I can come all the way down here and say, yeah, and say list map. Then I can go get square, Then my list, let me put my list outside there so I can say nums, which is going to be a list of numbers 2, 3, 4, 5, something like that. Then I can pass nums here. So this is my way of telling this guy to return the square of each. So it's going to go 2 square, 3 square, and stuff like that. So if we run this, we have 2 squared is 4, 3 squared is 9, 16 and 25. So instead of writing something like this is map. Basically, we are looking at map alone, and this is what map does. So how can we now combine map with a lambda function? So the way to do that is going to be to say, so I can come here and we want to write this exact code, and you're going to see how cleaner it's going to get. So I can say write the code at the top using lambda lambda function lambda function. So now, and it's easy, it's just a thing of, the function goes here, and that's what we want to do. You just want to replace the function with a lambda function. So I can go list map, and here, what do I need to do? I need to pass in the function, which in this case is going to be a lambda function. So I can go lambda, and it's going to be x, and the return is going to be x star star 2. And the next thing that goes in there is actually the list of numbers that we want to return, which is these nums that we've already created. But if we want, we can create a list one and say list range. No, that's going to be too confusing. But let me firstly show you that list range 10. So if we run this, we get, the um um square of each of the numbers between 1 and 10. Let me remove this so that it is not going to be too complex. Control X. So let me define a new function here, a new list here, and say let's call it numbers, and that is going to be like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We remove 0. So let me remove this one, and this is going to be numbers, that is this number. And let's see, perfect. So if we should run this now, we have 1, which is the square of 1, 2, 4, which is the square of 2, 9, which is the square of 3, 16, which is the square of 5, and all of that. So basically, instead of defining a whole function out somewhere, they're passing the name of the function into the map. So what we are actually doing is we are taking a lambda function and we are putting it in the map. Right. So that is how map works. So what about reduce? So the way reduce I said reduce. What about filter? So the way filter works is filter actually takes, okay, let's look at filter alone. So filter takes a function, and in the case of filter, the function must return boolean. So let's just copy this guy here and edit it so that we don't have to type a lot of code. So in the case of filter, let's just have filter. So we look at filter alone. What does filter alone do? So here, now let's say we have check even. We want to check even. I say check even, and it's going to take a number, and it is going to return x modulus 2 equals 0. Don't forget, let me show you what x modulus 2 equals 0 does. Or let's just come here and say 5 modulus 2 equals 0. That is going to be false because 5 modulus 2 does not equal 0. And if I should say 4 modulus 2 equals 0, this is going to be true. So this function here, this check even function here, defaults to true or false. So in this case here, I can now come here, instead of using map, I'm going to use filter and call check even, check underscore even. Do I have check positive? Oh, that is from the last script. So if we run this now, I think we have good. So let's run that. So it returns only 2 and 4. Why? Because only 2 and 4 is going to um turn out to be true. If we check even of 2, true, check even of 3, false, check even of this one, true, check even of the last one, which is 5, false. So we can also, I don't need to like show you that again. We can also do that with, let's copy this whole thing, actually the whole thing, and we edit it, Control C, then we can come here, Control V. So in this case, we are not, yes, we want to write the code at the top here with Lambda function. So all of this, we want to reduce it to just the um what do we call it, the even numbers. So we're going to say filter instead of map, and in case of filter we are going to say x, and the output is going to be x modulus 2 equals 0. So that is what we want to do. X modulus 2 equals 0. Perfect. So if we run this now for numbers here, we are good. If we run this, we get our output as, excuse me, escape. We have 2, 4, 6, 8, 10, which are the numbers that actually defaults to, that evaluates to true in this particular list. So that is how to combine Lambda function, a simple implementation of combining Lambda function with filter and map, right? And another thing that we could also do is we can do reduce, but reduce does not like exist just normally as this one. So let's quickly look at reduce and do reduce. And you have to import that, but we haven't gotten to importing stuff like that. The only time you've seen me import stuff is when we wanted to, I just wanted to show an analogy of um type annotation when we want to annotate with multiple things. But then let's just look at reduce. So reduce is part of a package within Python called functools. So I'm going to say from functools import reduce, right? So how does that work? So let's say I have, okay, let me just use this exact thing here. So reduce help us to like take everything within a particular iterable, just perform some elements to them and churn out just one single outcome. So I could come here and say reduce. So what it helps us to do is it performs like a rolling computation, right? So to reduce an iterable, like a full iterable to a single value. So we are going to say reduce then x. No, we actually have to do what are we even trying to do really? So what we are trying to do is, let's say we are going to be multiplying each of the numbers with each other as we proceed. So we can do x comma y. Then here is going to just be x multiplied by y multiplied by y for norms, right? For numbers. So if we run this, we get an error. So what is our error? Still coming up. Think I'm doing something wrong. And I do not know what that is yet. Let it come up. Still loading, still loading, still loading. Okay, it says int object is not iterable. Int object is not iterable. This is not an integer, is it? Okay, hold on. 10 items. Wait. Numbers is not supposed to be an integer. I'm coming. Let's come here. And we have, let's check it. We have numbers equals 1, 2, 3, 4, 5, 6. Then we have our product is going to be, oh, we should not list this. But let's remove this. And yes, we should just do that. Then maybe print out all of this. Or let's save it in a variable. It really does not matter. It really does not matter. So let's run that. Yeah, it does not. Yeah. So that works. Let's make it small. We shouldn't list that. So let's make it very small so that you can see what is happening, how we came to this um value. So the first one is going to be, 1 multiplied by 2, right? And the second one is going to be 2 multiplied by 3, which is 6. So if I had put, 4 here, that's going to be, I think that's going to be 24. 6 times 4. Yeah, 24. So 1 times 2, 2 times 3, 6, 6 times 4, 24. So that is reduce, and reduce help us to like do some rolling thing. If I should come here and do positive, so we are going to have 10, which is 1 plus 2, 2, 2 plus 3. That is going to be, what's 2 plus 3 again? 5, yeah. And like that. The next one also, till we get our final answer. So that is that on um that on reduce. So I really do not use reduce as much, but map and filter I use, way more than I use reduce, like way more. But I also do not like use lambda function a lot, because as you can see, we've covered comprehension before, and a few of the things, like a good number of the things that you can do with lambda function, you probably can do them with list comprehension, like in a much more cleaner way. But lambda function also has its place, and it is very, very useful. So that is it on lambda function, how we use them, how we combine them with map and filter, when to use them, and when they, and how they compare, how lambda function compares to a normal function. So thank you for tuning into this one. In the next class, we are going to be moving on to object-oriented programming, which is going to be um, um, a two-part class also, where we're going to be covering the basics, and we're going to be covering the concepts of object-oriented programming. So see you in that one. Bye.